Hello students, I am Sayon from the Department of Mechanical Engineering. In my previous videos about the welding shop, I have discussed about the entire welding shop. But in this video, I'm going to discuss about in specific about this gas welding. Okay, and I have prepared a PowerPoint presentation to discuss about this topic. At first, I'm going to the in detail of this topic, that is the gas welding. Basically, we are going to discuss about the gas welding, that is the oxyacetylene gas welding. That means two gases will be used for the gas welding, that is the oxygen, and another will be the acetylene. Okay, so there will be a fuel gas that we use for our oxyacetylene gas welding, that is the acetylene. Okay, the commercial fuel gases have the one common property, and they all require oxygen to support the combustion. Okay, to be stabilized the welding operations, a fuel gas when burned with the air or oxygen, they have some certain properties like high flame temperature, high rate of flame propagation, acquired heat content, this type of things. Okay, basically we are just going to discuss about the oxyacetylene welding. This is our main content. Before reading all the things, I'm going to discuss through a video. Okay, at first I'm playing a video that will discuss. Okay, we can see basically the gas welding procedure through this entire video. Here we can see there are two metallic parts that is to be joined through a gas welding operation. Okay, these are the edges that we have prepared. We know that the procedure of the how to prepare the edges. Okay, actually these white portions are we prepared the edges, and we have cleaned the edges. Okay, and we have held this our job in this holding device. Okay, and this is the filler rod. This is the standard specification that is written in this video. Okay, this is the welding torch. Through this torch there are two types of gases is used, that is the oxygen, another is fuel gas, that is the acetylene. Okay, we can see there is a flame in this gas welding. I'm going to discuss about these flames in my upcoming slide. Okay, yes, this is the full flame. Next, after this video, I'm going to discuss about in detail about this oxyacetylene gas welding. That is, we have to use two types of gases. One is oxygen, and another is acetylene. Okay, here we can see a picture of two cylinders. Actually, we can see two different colors, but this is not the actual picture of a oxyacetylene gas welding. In case of acetylene, we have to use the maroon colored cylinder. Okay, there is a standard color code as per Indian standards. Okay, so I'm repeating again, for the acetylene cylinders we have to use maroon current cylinders, and for the oxygen we use the black colored cylinder. Okay, that means the entire cylinder will be black. And another color code I want to mention, that is the carbon dioxide. This carbon dioxide not required for our oxygen gas welding, but in case of color that is similar to the oxygen, that means also the body of the cylinder in case of carbon dioxide is also black, but there is a difference between black these two cylinders. That means in case of carbon dioxide the neck will be white. This is called the neck of a cylinder, and this will be white in case of this carbon dioxide cylinder. Okay, and in case of oxygen cylinder the entire cylinder will be black. Okay, so there will be two pipes that are coming through the cylinders. Okay, and there are two types of valves of two cylinders. I'm coming in this topic later. At first I'm telling the parts of this total entire system, that is the two hose pipes. Okay, and this is our welding torch. This is the welding tip. Okay, and through this welding tip basically three types of flames will be generated, and here is the another accessories that we will require during our welding. Okay, here I am next coming to our flames that we can generate during our oxyacetylene gas welding. That is, the first one is neutral flame. Okay, another is oxidizing flame, third one is carbonizing flame. These three types of flames we can generate through this oxyacetylene welding. Okay, at first I am going to discuss about this neutral flame. Basically, in case of this neutral flame, we use both the gases in the ratio of 1:1 by volume. Okay, and this flame is used for welding of cast iron, mild steel, low carbon steel, and aluminium. That means, in this neutral flame, we have to use the same amount of oxygen and acetylene, and the ratio will be 1:1. There is a temperature difference between this portion and this outer portion. This inner portion is called inner cone. The temperature of this inner cone in case of this neutral flame is near about 32,000 degrees centigrade. Okay, and in this outer side, this is called outer envelope. Okay, and in case of this outer envelope, the temperature will be less than this inner cone, and here the temperature is already written. Okay, now I'm coming to the next flame, that is the oxidizing flame. In case of this oxidizing flame, we can see also two parts of these flames. That is the inner cone, but the certain difference is that it will be a pointed inner cone. We can see a sharp edge, okay, a sharp point of this inner cone. Okay, and also the outer envelope is also there, and the temperature of this inner cone is different from this neutral flame. Actually, we can generate almost 33,000 degrees centigrade. Okay, through this oxidizing flame. That means the temperature of oxidizing flame will be more with respect to the neutral flame. Okay, and for this type of flame we use excess amount of oxygen. Okay, I'm talking about this oxidizing flame only, and this type of flame is used for welding of oxygen free copper alloys, brush bones, and zinc based materials. Okay, so in case of this oxidizing flame, we use excess amount of oxygen. Okay, and the fuel gas will be less. Next, I'm coming to the third one, that is the carbonizing flame. Here we can see three types of cones. That is the inner bright cone, another is intermediate cone, and second one is outer envelope. Okay, and we can see different type of colors. Okay, the inner part will be very bright, that will be also sharp, and second one will be the reddish portion, which is the mainly called acetylene feather. Okay, that means in case of our carbonizing flame we use excess amount of fuel gas. That means in case of our oxyacetylene gas welding we use excess amount of acetylene with respect to the oxygen. Okay, that means the supply of the oxygen will be less with respect to the acetylene. Okay, and we mainly use this carbonizing flame for the medium carbon steels, and the temperature of this inner cone of this carbonizing flame is near about 29,000 degrees centigrade. Okay, clear? That means I'm just going to summarize all these flames. That is, the in case of neutral flame we are going to use the oxygen and acetylene in the same volume or amount, that will be 1:1. Okay, in case of oxidizing flame we are using excess amount of oxygen with respect to the acetylene, and in case of our carbonizing flame we are going to use excess amount of acetylene with respect to the oxygen. Okay, next I'm going to discuss about some reactions that occur in our welding process. Okay, basically the entire system has two types of reactions. At first, the first stage primary reaction, and another is second stage reaction. Okay, in case of the first stage primary reactions, two amount of acetylene will react with the two amount of oxygen, and it will generate four amount of carbon monoxide, two amount of hydrogen gas, and heat. Okay, and in the second stage reaction we can see the 4 amount of carbon monoxide will react with the 2 amount of hydrogen and and 3 amount of oxygen, and it will generate 4 amount of carbon dioxide gas and 2 amount of water vapor and heat. Okay, if we summarize these or combine these two equations, then we can get one final equation, that is the 2 amount of acetylene will react with the 5 amount of oxygen, and it will generate 4 amount of carbon dioxide gas and 2 amount of 2 amount of water vapor and heat. Okay, that means by this oxyacetylene welding we are getting the byproduct, that is the heat that is required to melt the metals. Okay, and it will help for our welding, and it is the primary requirement for our oxyacetylene welding. Okay. Here is also statement is written that I want to highlight, that is the when you combine equation number 1 and 2, you will notice that about 5 times of oxygen is necessary to consume 2 parts of acetylene. Okay, that I have already told through the equations. Next, gas welding procedures. But before going to the procedures, I want to mention one thing, that is the here I have already told there will be a valves. Okay, for these cylinders. Okay, actually oxygen cylinder valves are made of brass, and acetylene cylinder valves made of the steel. Okay, basically brass valves does not corrode too easily, and it is and that is why brass valves are used for the oxygen cylinder. But in case of acetylene, acetylene is very much dangerous gas because it can explode under its own weight. So actually we stored the oxygen in the cylinders like in the form of gas, but in case of acetylene we cannot store the acetylene in the means of the gases. I want to highlight one thing, that is the pressures of the cylinders. In case of oxygen, the pressure is near about 135 bar, but in case of acetylene the pressure is near about 15 bar. Okay, because in case of we increase the pressure it will explode. Okay, so we cannot store acetylene in the form of gases in the cylinders. Actually we use calcium silicate with the acetone. Okay, and the acetone will be dissolved in this calcium silicate, and it will react and generate the acetylene gas. Okay, that is why we are going to use separate types of valves, that is the brass and another is steel. For we use steel for the acetylene cylinders and we use brass for the oxygen cylinders. Okay, clear? Now I'm going to the last topic, that is the gas welding procedures. We are mainly going to use two types of process, that is the leftward technique and another is rightward technique. Leftward technique is also called forward welding process, and rightward technique is also called backward welding process. In case of this leftward technique process, the weld is made working from the right to left, and it is found most advantageous on the plates about near about 3 millimeter. Okay, so if we want to weld the thinner sheets, then we have to prefer this type of techniques, and if we want to weld the thicker plates, okay, then we are going to use this another technique, that is the rightward. Okay, so I'm going to the pictures so we can discuss about these topics. Another thing is vertical welding process, that is not required. Okay, next, this is the actual picture of a leftward technique. Through this picture we can see the direction of welding is right to left. Okay, and we are going to maintain some certain angles. This is the filler rod and this is our welding torch. Okay, it will be at 60 to 70 degree and the filler metal will be at 30 to 40 degree. In case of this leftward technique, and the direction of the welding I have already told, that will be right to left. Okay, and in case of this rightward technique, the direction of this welding will be from right side two left side, that means here. Okay, and here also there is a certain degrees that we have to maintain in for this type of weldings, welding techniques. That is the for the filler rod that it will be 40 to 50 degree, and in case of this torch, this will be also 40 to 50 degree. Okay, these are the standards that we have to maintain to eliminate any type of defects. Okay, if we do not maintain this type of certain angles or this type of things or this type of procedures, then the defects will occur. Okay, so basically this is our content for our gas welding process. So thank you for watching this topic. In my upcoming video, I'm going to discuss about the arc welding processes. Please, if you like this video, please like and subscribe my channel. Okay, so you can get the notifications of my upcoming videos. Thank you for watching.